Hello, today I'll be answering 14 questions about histograms. A histogram is a graphical representation of data that displays the frequency distribution of a set of data. The x-axis represents the range of values of the data, and the y-axis represents the frequency or the number of occurrences of each value in the dataset. The purpose of the histogram is to provide a visual representation of the distribution of data, which can be used to identify patterns and trends to make decisions based on the data. To construct a histogram, we first need to group the data into intervals or bins. We then count the number of data points that fall within each bin and plot the frequency of each bin on the y-axis. The bar of the histogram are then drawn to represent the frequency of each bin. The width of each bar corresponds with the width of the bin, and the height of each bar represents the frequency of the bin. The shape of a histogram can be determined by looking at the distribution of data. There are 7 common shapes that a histogram can take, including a normal, skewed, bimodal, and a uniform distribution. The shape of the histogram can tell us a lot about the data and can help us make decisions based on the data. The shape of a histogram can be determined by looking at the distribution of data. There are several can be determined by looking at the distribution of data. A skewed histogram is made when the data is evenly distributed around the mean. A skewed histogram, on the other hand, is when the data is not evenly distributed around the mean. Skewed histograms can be either positively or negatively skewed, depending on whether the tail of the histogram is on the right or the left side of the mean. The center can be determined by finding the midpoint of the range of the data by finding the mean or the median of the data. The mean of a histogram is the average of all the data points combined, while the median is the middle value of the data when the data is arranged in order. The mean is affected by outliers and extreme values, while the median is not. The spread can be determined by looking at the range of the data or by calculating the standard deviation of the data. The range is the difference between the highest and the lowest value in the dataset, while the standard deviation measures how much the data deviates from the mean. A narrow histogram has bins that are close together, and the data are concentrated around the mean. A wide histogram, on the other hand, has bins that are further apart, and the data is more spread out. Outliers of data points are significantly different from the rest of the data. They can be identified in the histogram by looking at the data points that fall far outside the range than the rest of the data, either on the left or the right tail of the distribution. Outliers can have a significant impact on the shape and interpretation of the data, and it is important to identify and analyze them separately. Histograms can be used in many different fields to analyze and interpret data. In science, histograms can be used to analyze experimental data and to determine the accuracy and precision of measurements by seeing if the data is more evenly distributed or skewed. In economics, it can be used to analyze income distribution and identify patterns and trends in consumer behavior. In social studies, histograms can be used to analyze demographic data and to identify patterns in social behavior and attitudes. A frequency distribution is presented in a linear graph, while a histogram is presented in a bar chart graph. That is the difference between the two. Except that difference, the two are basically the same. It's good because it provides a visual representation of the distribution of data, which can help identify patterns and trends. It's also easy to understand and interpret, even for those who are not familiar with statistical methods. The limitations, however, of using a histogram is that it can be affected by the choice of the bin size and sometimes be misleading as a result. To compare 2 or more datasets using a histogram, you can plot the histogram side by side and compare their shape and distribution. If the histogram has similar shapes and distribution, it may indicate that the datasets are similar or related. If the histogram have different shapes or distributions, it may indicate that the datasets are different or unrelated. To identify pattern or trends in a histogram, you can look for peaks or valleys in the distribution, as well as any skewness or symmetry in the data. You can also look for any changes in the shape or distribution of the data over time or across different data groups.